My name is Jivedinasha. So our project include predicting the quality of red wine using the mathematical models known as aggregation function. So introduction, the goal is simple, to create predictive model that can estimate the wine quality based on the chemical features. Here first I selected the manageable sample from the full data set, then explore the data to understand its distribution relationship. After that I applied transformation to make data modeling ready, and then I tested four different aggregation models and selected the best performing one. And finally I used that model to make prediction for the new wine and interpreted the results. Data overset. The red wine text file, it has 1599 samples, out of which from the project I have randomly selected 460 samples to speed up the analysis and keep things consistent. And I have included input variables, that is citric acid to bring freshness to the wine, chlorides to indicate salt content, total sulfur dioxide to preserve the wine, pH to measure the acidity, alcohol, which strongly impacts the taste and strength, and the variable quality. And I began my analysis by creating scatter plots for each variable against the wine quality score. This helped me analyze which variables are worth keeping. And here are my observations. Citric acid was highly positive relationship, but it was spread out. Chlorides were most clustered at the low values with the weak end. Sulfur dioxide was heavily right skewed, so it wasn't strongly correlated. pH showed no pattern at all. It was scattered completely. Alcohol showed a clear first rate trend. And I decided based on this which variables to use in the modeling. Histogram, I also plotted histograms to see how each variable was distributed. Most of the variables was not normally distributed. They were highly right skewed and values are concentrated at the lower end. This is important because skewed data can reduce the model accuracy, so transformation is necessary. One quality itself was mostly centered around 5 and 6, meaning that was quality rating. And the variable selection based on the scatter plot from histogram, I decided to include four variables, that is citric acid, chloride, total sulfur dioxide, alcohol. I excluded pH because it showed no relationship or useful relationship with the wine quality. So I've used this four variable, which gave me good balance between predictive power and simplicity. Data transformation. Next, I transformed each variable to fix their skewness and make the pattern clearer. For citric acid, I used square root transformation to gently reduce skewness. For chlorides, which is very highly skewed, I used log transformation to compress the range. And for sulfur dioxide, I squared the values to emphasize the variation in high values. And for alcohol, I used reciprocal transformation to highlight low values more. And these transformations were chosen based on the ability to improve data distribution without distorting meaning. Normalization. After transformation, I used minimal small normalization and scaled it to 0 to 1, so that it ensures that all variables contribute fairly. Aggregation functions used. I have applied four different aggregation functions to model the data. WAM, weighted arithmetic mean, the simplest averaging methods with weight. Weighted mean with p equal to 0.5 emphasizes lower input value. WPM with p equal to 2, it gives more weight to higher values. And WOWA, ordered weighted averaging, which applies weights based on the rank rather than variable. This model helped me explore different ways of combining the variable and predict the wine quality. Model performance, error and correlation. Based on the model we have evaluated the model with four metrics, that is RMSE, root mean square error, average, absolute error, Pearson correlation, Spearman correlation. The goal is to find a model with lowest error and highest correlation with actual wine quality. We can see with each model we have found out the RMSE value, average value, Pearson value, and Spearman correlation. And we have with each model we have also calculated the best weights. And best fitting model. The best fitting performing model was WPM with P equal to 2. It has lowest RMSE and highest Pearson and Spearman correlation, although WAM has slightly lower average value. It was more consistent and balanced. So I've selected this for the final prediction. If you want, you can also see here everything is the lowest, and I have highlighted here. And then prediction and interpretation. I then use the best model to predict the quality of new wine with the following values. The new wine has this following values. And I use this values transform normalized using the same steps you have used in the data training data. And then the model predicted the quality of score of 6. This suggests that wine is of good quality consistent with most wine in the dataset. Variable importance. The model also gave the weight for each variable. So alcohol has highest weight, about 66%, showing it was the most important factor. Sulfur dioxide and citric acid has moderate influence. Chlorides has least impact, so alcohol level in the wine is strongly indicative of overall quality. So best conditions for high quality wine is nothing but high alcohol content, moderate to high citric acid, low chlorides, balanced sulfur dioxide. This results not only confirm what we have found in data but also align with real world winemaking. Model limitation. No model is perfect. It has some limitation. Here, the limitations include we have used a small proportion of data. We left out one variable and did not test out, and we did not capture real world complexity. And also, it needs transformation need to improve accuracy. Ethics and data privacy. While the data set is completely anonymous, it is important to know that ethical use of model is critical in the real world. The data should be fairly used, and we should maintain the privacy. And conclusion. In summary, we use aggregation function to build a predictive model for the wine quality. After analyzing, transforming, and modeling the data, WPM with equal to the most reliable model. A prediction for the new wine was score 6. Indicating good quality, we all also understood which factors impact the wine quality most and discussed limitation and ethical concern. This project highlights how data-driven approaches can be used even in traditional industry like winemaking. And thank you.